What's up, you freaking geniuses? So in this video, I'm going to teach you how to find the linear and angular speed of an object that's rotating in a circular motion, all right? So as you can see, we got this pretty picture right here of a wind turbine, and it gives us the length of the blades, which is 116 feet, all right? So the problem up here just says the blades of a wind turbine are 116 feet long. The propeller rotates at 15 revolutions per minute. All right, so this thing goes around and around 15 times every minute, all right? So there's two things that we want to find. First part A says find the angular speed of the propeller in radians per minute, all right? So the first thing we want to find here is the angular speed. And to do that, we can simply use the angular speed formula, which is omega is equal to theta over t, where omega stands for the angular speed, theta stands for the central angle or the angle of rotation, and t stands for time. Now, angular speed, the units for angular speed, are normally going to be revolutions per some unit of time. And as you can see, the problem already gave us the angular speed, right? Because it says that the propeller rotates at 15 revolutions per minute. All right, so the angular speed here is going to be equal to 15 revolutions per minute. Now, the only thing we have to do here is basically convert this into radians per minute, right? Those are the units we're looking for. So how would we do that? Well, if we look at our wind turbine here and look at the blade, let's say this is our starting position right there. How far do we have to rotate all the way around to get back to where we started? Well, one full revolution is the same thing. If we're talking about degrees, that'd be 360 degrees. But if we're talking about radians, that's the same thing as 2 pi radian. Okay, so to make one revolution, that's the same thing as 2 pi radians. So here we're going to multiply by 2 pi radians per revolution. Okay, now you might notice we have some units cancel out, right? The revolutions on top and the bottom cancel out, and then we can just simply multiply straight across. So on top, we're gonna get 15 times 2 pi, so 15 times 2 is 30, right? So we get 30 pi, and then our units on top are radians, right? So we'll write radians, and then the only thing we're left with on the bottom are minutes, all right? So then here we get that omega is equal to 30 pi radians per minute, right? So that is the angular speed in radians. Okay, now lastly, let's find part B. So part B just says find the, this time, linear speed of the tips of the blades. All right, so there's a couple different ways we could do this. But one way we can do this is by using the linear speed formula that relates linear speed to angular speed, which is V is equal to R times omega, okay? So then here, this is gonna be equal to, well, R in this case stands for the radius. So what is the radius? Well, it's gonna be 116 feet, right? Because if we're talking about the tip of this blade, right, that would be that point right there at the very end of the blade. And then we basically just go in a big, kind of circle like that. So the radius again is going to be 116 feet. And then we're going to multiply that by omega, which is 30 pi radians per minute, right? So we're going to multiply this by 30 pi radians per minute. All right, now if we multiply this out, 116 times 30 pi, that's going to be equal, we'll round here. We're going to say it's equal to approximately 10,932.7. And what are our units? Well, on top you can see we have feet and radians, but radians are essentially unitless, okay? So really we're just going to have feet on top. And then what are we going to have on the bottom? Well, all we're left with is minutes, right? So it's going to be feet per minute, all right? So 10,932.7 feet per minute. Okay, and that kind of makes sense because linear speed, the units for linear speed, are normally going to be something like miles per hour, right? Feet per second, or in our case, feet per minute. So if you found the video helpful, make sure to leave a thumbs up down below. And if you have any questions, let me know in the comments section below.